What's up, world? YouTube. Beautiful, amazing, wonderful people out there. I hope that life is being extremely kind to you. I really hope that that's the case. And I send my good energy out to you. Right now, I'm in a place where I love to be. It always puts me at ease. No matter what the weather is here. If I'm near water, if I'm near a beach, a river, I'm in a good place. Even if it's pouring down rain, freezing cold, I'm in a good place if I'm near water. And I'm, while talking to you, watching this amazing, incredible sunset. Well, it's not setting yet, but it's gonna set soon. And it's really incredible. And you know what? I'm just gonna let you, I'm gonna share this with you. This is meant to be shared. It's not meant to be explained. Really beautiful, right? Yeah, tropics. I love it. I can't believe I haven't spent the majority of my life in the tropics. But I'm here now, and I get to learn all about it and experience it. Okay, so what am I going to talk about in this video? What's the focus of this video? You already see it in the title. I'm going to talk about mitochondria. And I know some of you's heads are already hurting already. Oh my God, mitochondria, such a abstract, boring thing. But I'm going to try my best to make it interesting, because for me it's already interesting. But I'm going to try to relay that passion out to you and explain why I'm so passionate about it. Well, the focus of this video is I'm going to explain two things. And you see the title. The title is it's all mysterious and stuff. Mitochondria, goddess of death and life, or life and death. And I'm going to explain why that's the title of this video. I'm going to explain why in telling you or talking about how mitochondria make energy for our cells, and also how mitochondria are the judge. They make really important decisions on whether to end lives. So mitochondria have a really tough job. Really tough job. And I'm also going to explain why I'm calling mitochondria goddesses. That's relevant also. Okay, so the two things that I'm going to focus on in this video are how mitochondria make energy through respiration. That's the scientific word, respiration. And I'm also going to talk about apoptosis, when mitochondria get the cell to commit suicide or get it to die, and why this is a good thing, and why it's a tough decision for the mitochondria. Okay, so before I go into that, let's talk about why this is even important in the first place. Okay, you could replace, if you see the word mitochondria in the title of my videos, you could replace the word mitochondria with beauty advice, strength advice, longevity secrets, anything of that nature, because that's what I think about when I'm learning and see the word or talk about mitochondria. That's what's running through my mind, stuff like that. Because a mitochondria is, to the best of my knowledge, what streams us consciousness. It provides energy, heat, life, anything that you view as components of the soul. And mitochondria have to feed in order to provide that energy. So what are they feeding from? Where are they receiving this nutrition, this food? I mean, we know oxygen, we know electrons, and there's a lot more to it. There's more physics that is feeding from, and other things that is feeding from that we don't have names for yet, or even are aware of. But let's keep this simple. Mitochondria are really important to me because they are the foundation of biological energy. We start talking about biological energy, you start talking about health, longevity, beauty, and just total upkeep of a biological system. It all begins with mitochondria. So, you know, I'd rather just go straight to the source, not and skip the middle people, middleman, middle women, whoever, and go straight to the source. And the source to me is mitochondria. Not, I mean, there's other things that are important. You know, it's important to eat a healthy diet and get fresh air, things like this. But ultimately, it's gonna boil down to the strength of the mitochondria and the ability of the mitochondria, which is why I focus on it. Okay, so another common belief of many people is that the DNA of our cells determines our fates. The DNA of our cells determine our fate and what's going to happen to us and how we act and how we express energy. But that's not my belief. My belief is that the fate of the cells is determined by the mitochondria, because the mitochondria provides energy for the cell. The cell just does its job. The cell cannot make, the cell has very limited ability to make energy. The cell just carries out instructions, really, of what it's supposed to do. But the mitochondria provides the cell with energy, consciousness, heat, light, all these things that are we think about when we think about life and consciousness and just feeling alive. So mitochondria govern the fate of a cell. The cell must have the mitochondria, and it even goes deeper than that. Mitochondria give the cell life, and they also decide if the cell must die or not, or if it's fit to live. Mitochondria play God for the cell. And let's talk about DNA. DNA of a cell, 50% comes from our mother, 50% comes from our father. Now the mitochondria has its own DNA also. Even though it's a part of a cell, it's one organism, but mitochondria has its own DNA, separate from the cell. And all of that DNA comes from the maternal line. So if you want to know how healthy you are, look at the health of your mother, her grandmother, her great-grandmother, and so forth. And that'll tell you, they'll answer a lot of questions to you about why you express energy in the way that you do. It'll answer a lot of questions for you. And that's part of the reason why I'm calling mitochondria goddesses, because we get the energy and all the things that are associated with mitochondria from the maternal line, from our mothers and our mothers' mothers and mothers' grandmothers and so forth. And even if you know about, or if you believe the theory that we all come from Africa, some 170,000 years ago, the way that they came to this conclusion for this theory is through mitochondrial DNA. And mitochondrial DNA can only be traced down the maternal line. And they supposedly took the DNA from a bunch of different random people, and they traced all of those people's mitochondrial DNA, and it all went back to one female. So that's how they came up with, we evolved from Africa approximately 170,000 years ago. All right, so enough about that. Let's get into what this video is about, the two things that I'm going to focus on. mitochondria, or how are they goddesses of life? Mitochondria are goddesses of life, and I'm going to explain this by talking about cellular respiration. Cellular respiration is basically where we eat food through a whole process that is beyond the scope of explaining for this video, but the food's broken down into small units, and the most important unit that I'm going to focus on here is electrons, and the electrons are fed to the mitochondria. The mitochondria receives the electrons through an organ on the mitochondria called the electron chain transport. The electron chain transport is a chain of complexes: complex 1, complex 2, complex 2, complex 3, complex 4, and so forth. And these complexes, each one breaks down the electrons into simpler and simpler electron structures. And each time it breaks down the electron, it releases energy. Now, what's an electron? If you notice, we're not talking about protein, fat, or we're not even like talking about food. The common energy we see when we look at the nutrition facts on our food. We're talking about straight electricity here, or solar electricity, solar radiation, however you want to look at it or call it. So we're not even talking about, we're talking about straight energy right now. So mitochondria receives the energy stripped from food through the electron chain transport. Remember electron, electricity, negative electricity, and goes through the complexes. It scripts the electron, releases energy. It goes to a respiratory protein takes it to the next complex. Respiratory protein, for example, it's called cytochrome. It takes it to the next complex. It scripts the electron again, releases energy. And if you remember, I talked about cytochromes in my sun gazing photosynthesis video, and how the cytochrome carries the light that is delivered from red blood cells to the mitochondria. So keep that in mind. I'm laying the foundation for a future video, so keep things like this in mind. And after the electrons go to all the corresponding complexes that they need to go to be broken down into it's the simplest form that it needs to be broken down to, then it's accepted by oxygen. Oxygen is an electron acceptor, and after the electrons are accepted by oxygen, ATP is made. What is ATP? ATP is chemical energy. Energy that has to be, it's in a chemical package, and it can be broken down and used by the cell. And also it creates protons. Protons are energy that's ready to go. And ATP and protons are pushed into the inner mitochondrial membrane, and once they build up, the polarity eventually pushes them out of the inner mitochondrial membrane, past or through the outer mitochondrial membrane into the cell, which gives the cell, it provides energy for the cell. So in a nutshell, that's how mitochondria make energy for the cell, through cellular respiration. But there's other ways, and I just gave you the most common, most popular way that everyone knows about, most people know about, which is cellular respiration. Now, let's talk about how mitochondria are goddesses of death. How do they kill cells? Why they kill cells? And why this is even important. Alright, so right now I'm about to talk about apoptosis. What's apoptosis? Well, I'll explain first. We'll come back to that word. But our cells are quite, they can be quite selfish. They want to live forever. They want to enjoy themselves. They want to be free, kind of just like us. But just like us, they have a job, they have a purpose. You know, each cell in our bodies, they have a certain purpose, and if they don't do their job, they don't serve their purpose, then, you know, it could be detrimental for all the rest of the surrounding cells, detrimental for the organism, and ultimately detrimental for the organism. So it's important that they pull their weight, and it's important that they stay healthy. If they get too worn out, they either need to be strengthened, or they need to be replaced, or simply gotten rid of. And also with the cells, sometimes cells get like brain damage, and I guess we call this brain damage DNA damage, where they no longer follow the rules anymore, and they become renegades, and they're on their own program. They want to live forever, and they just want to do anything they want to do, and they no longer care about anyone else, and they want to reproduce and create copies of themselves that also are renegades. And this can be chaos. It will be chaos for the entire system, and of course, you know, something has to be done about this, or, you know, it's going to be big problems later. And this is an example of cancer, when you have a renegade cell like that. And when you have a cell that's all worn out and no longer useful, this is an example of sickness. So this is really important. So at this point, apoptosis, or cell death, cell suicide, becomes really important. Now, who does this? Whose decision is this? Who is the judge and the jury, and who's the god that makes the goddess that makes the decision for this to be? It's the mitochondria. Mitochondria have to make this really difficult decision. And the mitochondria, they all don't want to kill the cell. They don't want to make this tough decision. They all have to come to a consensus about it, because ultimately, if they kill the cell, they kill themselves. They commit suicide. And some mitochondria are like, I don't want to die. I don't vote to kill it, because then we die. But if there's enough, if there's enough mitochondria that are altruistic and they care about the bigger picture for the cells, for the organism, and that universe that they're in, then that's what happens. The cell dies. The cell gets killed. And ultimately, this is a really good thing, because, you know, we live to die. We have a purpose, we have a journey, we have to serve it, and we have to serve it responsibly. And in the cellular world, it's no different. It's funny how microcosms can imitate. It's funny how macrocosms can imitate microcosms, or microcosms can imitate macrocosms. Sorry, I got a little confused on that. But that's what I wanted to talk about in a nutshell. How mitochondria are gods and goddesses. Goddesses, because they come from females, of life and death. Now, I made this video as like a foundation for future videos, because I want to talk about, because in the future I want to talk about things that are actionable, that we can take the information and use it right away, or test it right away to see if it's true, or see if it is even useful, or can help us. But in this video, this information, you can't really use it. All it does is just set the stage for later things that I want to talk about in regards to mitochondria, which will be useful, such as mitochondrial DNA. Knowing what type of DNA that your mitochondria has can help you be like the best version of you, because certain DNA gets the mitochondria to do certain things. For example, some mitochondria make lots of heat, some mitochondria make lots of energy, and lots of other different types of in-between energy of heat and pure energy. And this is dependent on the type of environment that you're in, that you put your mitochondria in. So I want to talk about mitochondrial DNA in the future, and talk about how we can use knowledge of that to better ourselves and to get the most out of ourselves. And that can mean by physically going to another geographical environment, or actually creating that environment yourself. And I want to talk about how mitochondria react to the cold. I've already done cold ice bath videos, and I start talking about mitochondria there. You know, those are already kind of mitochondrial videos. So I'm going to go more in depth in the future about the cold mitochondria, and how mitochondria respond to lots of light. I'll talk about that. I've already done it in my sun gazing videos. I always allude to mitochondria and how they come into play when I talk about sun gazing and sunlight, because they tie together. And I also want to talk about how electromagnetic environments affect mitochondria. And like, our environment has dramatically changed over the past 150 years, and we need to really educate ourselves on these changes so that we're not blindsided by detrimental effects that can just happen out of the blue. This is a brand new situation that our mitochondria are being exposed to, and they haven't had an adequate amount of time to make that adaptation. 150 years, and they say we've been here for 170,000 years. 150, 170,000. No, mitochondria don't evolve that fast. So I think it's real important, and I think it's a conversation that needs to be had. So that's my video, and thank you for sticking around and checking it out. Really appreciate you, and I love you. I love you. You love yourself. And please like, share, subscribe, comment, browse my channel, and I'll see you next time. I'm out.